Hello everyone. Today we are going to discuss about minimum spanning tree. So the minimum spanning tree is a subset of edges of a connected edge-weighted graph that connects all vertices towards without any cycle and with the minimum possible total edge weight. It is a way of finding the most economical way to connect a set of vertices. So a graph is given. If you want to find a minimum spanning tree of a graph, we are just eliminating the edges of the graph in order to avoid the formation of the cycle. So in this way, it should be an economical one, um, providing a path from source to the destination. So here we are using Prim's algorithm for finding the minimum spanning tree of the graph. Is one of the efficient method to find the minimum spanning tree of a graph. So the minimum spanning tree is a subset, is a subgraph that connects all the vertices present in the main graph with the least possible edges. So that is very important. So we are going to eliminate the unwanted edges based on the cost and minimum cost, that is sum of the weights assigned to each edge, each link. So this is the graph given. We have to find the minimum spanning tree for this graph. So at first what we have to do, we have to uh, create a visited array to store all the visited vertices into the graph. So here at first it is empty. uh, what I have to do, I am just choosing the source vertex as yes now, and I have to find the adjacency of the source vertex, and the which means the S is connected with adjacency of S. So among that two vertices, I have to find which one is having minimum cost. So here S and B, so it is having less cost 8. So I am adding S with the 8, S with B, and next is uh, B is the last visited. With B, I have to consider what is the adjacent vertex of B. So now B with B, A is connected, C is connected, E is connected. So among these three, minimum cost is A, B to A 9. So I am just adding A with B. Okay, 9 now. So hence B to A is the edge added to the minimum spanning tree. And next I have to traverse with A. So A to C, A to B, A to E. Okay, so among these, which one is having less cost? A to B 9. So I am adding uh, B into the list. So S to B, S to A, S to E. Then finally from E, C and D are their adjacency. So 3 is having the minimum cost, that is D is having the minimum cost 3. So I am including D here, ED. Okay. So since D is the last visited, check for the least cost edge that is connected to the vertex D. So D to C is 15, E to D is 3. Therefore D to C is added to the spanning tree. So this is the final minimum spanning tree yielding S to B, B to A to E, E to D, D to C. So this is my final minimum spanning tree for the given source graph. So when you add this edge weights 8 plus 9 plus 11 plus 3 plus 15, we yield 46. We get minimum cost is 46. So that is the cost of this minimum spanning tree. So we have reduced, or we have eliminated the edges from the existing graph. We have eliminated some of the edges, and this is the resultant minimum spanning tree of the given graph. So initially I have chosen S as the source node, and from S we have found the adjacency of S, B and other vertex. So among those two vertex, I am choosing the minimum weight each time. So likewise, I am finding out the minimum spanning tree. Thank you.